can't. But it is. It's paradoxical, and yet it works.
Hello Ziad. So a student uses two cells, each of EMF 1.5 volts and internal resistance 0.65 ohms to operate a lamp shown in the figure. So what you've got, each one of these is 1.5 volts. And they also have a little resistor of 0.65 ohms. 0.65. Okay, so as you know, if you have EMFs in parallel, as an electron, you will not go through both of them. You'll only go through one. So your total EMF would be 1.5 volts. However, even though you're only going through one of the internal resistors, you've got two internal resistors in parallel. So obviously the total internal resistance now drops. So you could do 1 over R1 plus 1 over R2 and then do 1 over the answer. But because they're identical, and you just do the total internal resistance is just simply 0.65 over 2. Okay, so just put that into your calculator, 0.325 ohms. So now what you've got a scenario where you've got 1.5 volts, 0.325 ohms in a circuit with, and we're going to call it just big R. Okay, why are we doing that? Because that now, if you remember the formula for internal resistance is this, isn't it? Now, would you use this one? Well, we don't know V. We're trying to prove V, and we're trying to prove P as well, aren't we? I guess so what you need to do, I'm going to rewrite it as IR plus R. Okay, so that's one of the versions. So we're going to work out current first. So that's just E over R plus R. Okay, so E is 1.5, and then big R, we've got to work out now, haven't we? So you've already done it there. You've got an R because you've got the power and you've got the voltage. So the question is, what formula connects them with resistance? So power equals V squared over R. Okay, so we can now work out the resistance of this bulb. So in this case, 1.3 squared over 0.8. So if you put that in, you get about 2.11 ohms. Now you've already got that here for some reason, and then you stop for some reason, as you seem to be doing. Okay, so we can now put that into our formula for current. So 1.5 over 2.11 plus 0.325. So we can now work out the current. So if I put all that into the calculator, I get 0.62 amps. Now you've actually worked out the current it needs. So you've done I is 0.8 over 1.3. So if you compare them, you could actually say, yes, it gets the current that it wants. And there you've got to work out, well, does it get 0.8 watts? So then you could just put that into P equals I squared R. So it's got the current that it needs. So if you put 0.62 squared times by R, which you worked out, 2.11. So you seem to be getting halfway there and deciding to turn around for some reason. And then if I put that in, I get 0.81 watts. So does it get the power? Yes, it does. Okay.